Okay, Jason. One question. When you started with Java, what was your first project or your first program, or how you found Java, the road to Java?
So it's interesting because I had looked at Java when it was like the very one of the very first releases. It was like hot Java when you could only run it on Spark. Um,
Hmm.
but that was purely just sort of getting to know it. And the funny thing was that when I first used it, I really wasn't that fond of it. I was kind of originally a C plus plus guy, so um, so at first I wasn't a huge fan, but then afterwards I had some projects where uh, there was a lot of benefit in using it, and then I started to really appreciate it, and now I could imagine going back. But probably the first major applications that I developed with it were in telecommunications type
Hmm.
sector. So doing lots of sort of like data processing type stuff.
Okay. Similar on my side. So if I saw the applets the first time, I couldn't believe it. It's like, what's that? So I didn't knew the Duke. So what's up with the Duke? And this was like very strange experience. But then I also started with server-side Java, strangely enough. So a few applets, some chats, but then stick with the server. So what you created for the telco industry?
The area that I worked in was essentially we were building an ISP,
Hmm.
and so we had a lot of stuff that was that was written as native daemons, native servers, and then we started to use Java as a way to bring in more people because not a lot of people have sort of like Unix native C development, and then
Hmm.
it's sort of like the productivity benefits of it really started to take hold, because you could have decent sized team produce something fairly quickly. So like the types of applications would be like sort of like provisioning based applications for setting up equipment, telecommunications equipment for routing customers, or it could be interfacing with billing systems, things of that nature.
Hmm.
But yeah, I mean, there was web-based applications. I mean, it was all server-side Java, but it was more like SE applications initially, and then we started moving, web-based aspects to an
Hmm.
application server environment.
What was your first server?
So that was interesting because I looked at a lot of app servers. So originally, I think the first thing I was using was like an earlier Tomcat
Hmm.
release, and then I I played with a bunch of different ones like Orion, and then eventually ended up settling on JBoss, and so that's sort of like how all of this started. Is I was originally a user of JBoss, um, developing his version, primarily version 3, um, and and then from there we started using a lot for in building integration systems. We had like in that location we had a whole Windows shop that was building all kinds of stuff, with Microsoft technologies, .NET stuff, and then a bunch of sort of what do you like business process management software,
Hmm.
and that was heavily integrated web services based. So that was partly how I got involved with JBoss was as we were building this integration stack. There was a lot of problems in portability of the web services implementation between all these different frameworks, and so I was submitting patches up to a bunch of different things.
Hey, cool. Um, so what is your impression of the early server-side Java? So you tested lots of servers, so evaluated lots of servers. So you like that or not? So what were the early days?
So I mean, I really did. I really liked I really liked the servlet model. So that
Hmm.
was like sort of my first impression in building applications because everything else, all the other web technologies were doing the whole you know build up tear down approach to
Hmm.
computing. So I really liked the threading model that was with servlets, so that you could write something and then handle a request, and then you're not actually having to lose state. You could do much more higher performing applications. And then I found the component model aspects of server-side Java development very compelling. Just from a standpoint of sort of like good software architecture, and then having test-driven development aspects where you could break up your application, sort of separate business concerns. I thought that was a pretty powerful thing. So my team was heavily using things like EJB, and it was at the time it was pretty compelling stuff. So I still think it's evolved quite a bit. So if I was building an application today, I would still be very much drawn to the programming model.
Yeah. So it's interesting. So you started already with Java E, right? So Java E were already out.
Yes.
So these were.
Yeah. So originally, when I was looking at Java in the earlier days, it was more SE based applications. But then it was looking at Tomcat. Servlet was the first Java programming model I ever looked at, and from there, yeah. So I probably started looking at Java. It was Java EE 1. It's either 1.2 or 1.3, I believe. Primarily, I was using 1.3, but I can't remember exactly which version I looked at first.
That's interesting, because I started with server-side Java before Java J2E, and the problem was, so you got servlets, you got EJBs, you got JMS, and there were, I would say, around 50 different application servers, and each one had a complete different set of APIs. And for me, it was impossible to understand, two application servers at the same time. So I was completely, I couldn't even, implement something reasonable, because the servers were so different. And then J2E came out, and this was for me like, oh man, this is the really thing, because now I can rely on this set of APIs, and this was a huge simplification. But you already started with the J2E, so you don't know the advantage of it, right?
Right. Yeah, I missed that era where everything was completely proprietary.
This was crazy times. This was persistence powered here. I don't know. This was a server which was half Java, half C++, and there was Tenga. It was the predecessor of BA. It ran on Novell, NetWare, and Bolland, and Java Web Server, which was just servlets from Sun Microsystems, for instance. And then I think you didn't start it with Tomcat, rather than it was the Sun Web Developer Kit, which was the predecessor of Tomcat.
Yeah, I remember that now.
Right?
Yeah, that's right.
Yeah. And then there was a Jigsaw project from Apache, also a servlet engine, which I evaluated. But the point was, I read the whole time, all my free time, all my time, and I couldn't understand, how it's possible to be productive having so different environment. And yeah, this is why I like actually Java E. This is why I still stick with it, because it's actually great. You just rely on the thing, and you can be productive.
Yeah, it's interesting. That was one of the things that was nice, was that we had cases where there was applications that were completely written for, I believe it was some old version of WebSphere that came in, and then converting those over was really not that. There's a lot of proprietary hooks still, right? But it's still, converting over was fairly simple compared to other architectures. If you write, for example, like because when I was doing a lot of native development, we would write like native plugins for, say, Apache, or for the Microsoft server stuff, and those APIs were completely, totally, like, there's no similarity at all, right? so I can relate from that standpoint. But that's the thing I always liked about Java, was just that whole like write once, run everywhere thing. I thought it really lived up to that. So it's great.
So cool. So, and then you became a JBoss user, and then you were hired by JBoss or Red Hat?
Yeah. So when I started noticing problems with the web services stack. So it was based on Apache Access at the time, and the issue was that sort of the web services world was moving towards the schema based processing for Because before that, there was RPC encoded, which is SOAP encoding. And the access stack was written, was written from the perspective of RPC encoding, so it really wasn't designed for doing schema-based stuff. And essentially, the guys that were working on it at the time, they put in a lot of stuff to make it work, but it had issues. So I was just sending in a mountain of patches, getting it working where I was at. And then I got an email from Thomas Diesler, who was heading up that area, and he's like, "Hey, how would you like to do this for for a living?" So
okay,
that's how I got started. I mean, I had been contributing to open source projects, for a while, and I thought, to me, it was always like a nice hobby type thing. It was really great.
But when you did it at night, or
night weekends. I just like to hack on something sort of really technically challenging. And I like the collaborative development process behind open source. It was quite a bit different than the business world interaction and stuff like that. So it kind of drew me in.
But I have to admit, I would never contribute to SOAP. I have to say, I never got it, because I did a lot of stuff with CORBA, Genie, and RMI, and then SOAP came out, and I said, what is that? Because it's not a real improvement. It's just like the whole idea of XML is somehow nice, but it's never used. It was actually completely exaggerated in the companies. It could even work, but what I saw, XML everywhere in the databases, they just blew up because they became too big, or just the attempt to standardize everything. So I didn't like SOAP at all. So this XML, how it's called? XML RPC. This is what I used. This was the predecessor of SOAP.
Oh, right,
so this is what I like. It's very lightweight. This was like RMI over ASCII, I would say. And then SOAP came out, and I only use it because sometimes it was the only way, to talk through the firewall. So this was the main advantage, because with the old binary protocols, it was impossible to talk between servers. And you like SOAP back then?
Well, it was. So it wasn't so much that I liked it. I mean, I still think that IOP was a really powerful protocol. Just the way that they designed the whole encoding mechanisms and dealing with different platforms, different byte ordering semantics and stuff like that. I thought it was a really nice technology. It was kind of interesting because even though it had the portability, there was still like lots of problems with implementing it. And I think some of it is just from the assumption that a lot of it's designed around the assumption that the whole network is flat, right? Or locally accessible, and then any point can call out to any point. And I think that hurt its adoption relative to other technologies. But yeah.
But Jason, if you take a look at, for instance, gRPC or Thrift and all the technologies, they are extremely similar to IOP, right?
Right, exactly.
To CORBA.
Yeah, so they kind of took away the parts of IOP that were problematic, right? Yeah. Yeah, exactly. Yeah. So I mean, one of my that's actually one of the things I think about. So like I like the philosophy of REST, for example. But I think one of the things that's difficult compared to, say, like Java serialization or what IOP had is just the mapping of the data model to wire format, and then back to your to whatever object model you're using internally. It's interesting because there's a lot of challenges in writing protocols where you have to care about things like compatibility, like versioning of your protocol and things like that, and stuff like gRPC or they're thinking about these problems, and they have the protobuf stuff has semantics for that sort of thing, but if you look at like REST applications, you're sort of taking something and then you're doing like a JAX-B sort of approach, or just directly taking the object and throwing it out to the wire, and so I think you end up with some code more in the application. So it'd be interesting to see how that evolves in the future.
So what happens in my observation in enterprises, you probably know the data transfer object pattern, which is not really efficient, because what developers tend to do is they create a DTO which is somehow automatically serialized over the wire, and then they have an entity which is stored in the database, and they map between both objects, and and they are mostly identical. So it's just waste of time.
Yeah, exactly.
And meanwhile, what I'm doing, I ditch the DTOs completely, and the entities are just serializing themselves to JSON. So there is a method to JSON, and what they are returning is JSON object from JSONP. And with Java 8, we get a very, I would say, pragmatic version of that with JSONB. So the new DTO could be, just POJO with public fields and nothing else. And I think could be even a good thing to have a decoupling. So because we are often forced to serve JSON objects for web apps, and they have to be simple. So if you would, send our whole Java object hierarchy, it would be really harder to consume for the clients. So I think the perfect serialization and deserialization of Java object might be overstated a bit, because even if we were capable of doing this, we would still have to map or decouple from the internal representation, right?
Right, exactly. Yeah, I mean, I think that's the key thing is having some form of separation between what you're sending on the wire. And I agree with you completely that the DTO pattern has been problematic just from a bloat perspective. But yeah, I mean, JSONB helps a lot. So I mean, I think that's where the REST pattern is great because it standardizes the sort of the common access patterns and makes things a lot easier. Versus that was the issue with web services, right? Is you have to have you can't consume it without having a tool generate a bunch of code for you, right? It's just not practical. But with REST, you could get away with just throwing together a GET request and then you just get an object back and you deserialize it. So I think that's going to evolve further. But yeah, I mean, I think JSONB helps significantly. So yeah, if you could get those DTOs down to a small size, just a few sets of fields, and then you have a copy operation, it's great.
Cool. So then you became the SOAP guru at JBoss.
Yeah, so I worked on the web services team. So that was really interesting because we basically because we were going through that transition of SOAP encoding to to schema, we re-implemented a whole new web services stack as part of that was schema knowledgeable, and that greatly improved our interoperability. But then what ended up happening is there was so many WS star specs that were coming out, and then the community, a lot of web services projects started forming. So what we ended up eventually doing was moving with using CXF. So we switched from our native stack to a layer on top of CXF, which that's still what's in use today for our web services implementation. It's based on CXF. So. But yeah, I mean, so that was kind of the first thing I did was working on that, and then areas of the server that were associated with EE compliance and issues there. And then I moved into clustering after web services. I was on working on JBoss Cache and the project that then became Infinispan.
Oh, cool. So you and one question about JBoss. Was it the era of Mark Fleury? So you know Mark Fleury personally?
Yes, yeah. So I joined so I was a contributor in 2004, and I joined officially joined in 2005. And I mean, I still remember, I flew in it was JBoss World Atlanta, and it was the first JBoss World conference, and I flew in. I think my wife will probably never really forgive me for this, but I left at the end of our honeymoon. We went
okay
to enjoy right after I got hired, and no, everything's cool, but it's funny. It's right at the end, I gotta go to this thing, and so I went, and it was a small room with maybe this was not just the whole conference, but the meeting, the development team at JBoss at the time. It was a small room of maybe 20 to 30 people, something like that, and that was it. That was the whole. That was JBoss. So that's what I joined. So I was in the early enough time to where, yeah, I knew Mark personally. I knew all the original guys, and then yeah, I've been there ever since. So it's been a great journey.
It's a cool spirit, I think, right?
Yeah.
So it was and then you became, so you started with clustering and JBoss cache. So I think I know Manik Sultani, right? So he's one of the JBoss cache leads as well. So we met at conferences. And so what is your job then? Was like conceptual work or just hacking the cache or what was it?
Right. So when I joined, I was leading a project that tied into JBoss Cache that was called Pojo Cache. And basically what it did was it did AOP bytecode interception of objects and then transparently mapped those objects directly to the cache.
Okay.
And it was kind of like, if you sort of compare it to like it had a similar philosophy sort of to, well, I really shouldn't compare it to JDO, but it's sort of the idea that the second that you invoke a method, something happens right away. Versus what we ultimately decided to do to take the direction was to do more of an ORM style approach, like Hibernate uses, where we map. So you have a live model that you're working with, and then we map it in a similar way to what JPA works to writing it, to persisting out to the cache store. So like JDG right now uses that approach. But yeah, so it was all cutting edge and stuff, and with complicated problems to map, for example, Java arrays into cacheable types that were clustered. And then I did a lot of patches with the overall architecture with JBoss Cache. I worked on the locking model and sort of state transfer algorithms to optimize the when nodes join a cluster. So that was a really interesting area to work in. So I did first the web services stuff, and then I got to do clustering stuff, which is totally different.
Yeah.
And that was probably closer to my interest because I tend to like lower level technical stuff in general. So we got to do lots of sort of algorithmic type problems to solve those. It was great.
But interesting, with the JBoss cache, I remember back then, so you always had two choices, synchronous replication or asynchronous. And the synchronous would block everything and lead to deadlock, and the asynchronous was very fast and scalable, but not consistent. So even then, you always had the two choices, like the CAP theorem, So it was... And people believed back then if we just use JBoss cache or now Infinispan or Hazelcast or whatever, it will solve the problems. But you always have to decide, would I like to have more consistency or more scalability? And I think with the JBoss cache, it was a tree cache first. So this is what I used it first. It was like, it was a tree based, and then they migrated to hash map, right? So, or not to hash map, to a map based. And then it became Infinispan, right?
Right, exactly. Yeah, that was the key. A lot of the reason why it was tree-based was because it originally had a synchronous locking model, where so like the locking pattern, in order to make the locking pattern optimal, the tree structure became really important. But then we moved to a MVCC locking model approach, multi-version concurrency control. So it's more like you're working as a snapshot of isolated states. So it's much more acid-like you would if you were operating against a database. And then the tree model aspects weren't as important, and also that it was more natural. We always felt it was more natural for a developer to interact with just a straight map. But there were still a lot of diehard fans of the tree structure. Because they architect their application around that structure, right?
Yeah.
So.
I believe that, yeah. And exactly. And then you introduce even isolation levels for the cache, right? So you could set up the isolation levels about, the isolation of the transactions during the synchronization, right?
Right, exactly. Yes. Yeah.
Yeah, perfect. And then you stick with the cache or clustering, or what is your next, goal or your mission at JBoss?
So what happened was I was working on the clustering stuff, and I really enjoyed that. And then Sasha at the time was looking for who should. He was asking for who was interested in the EE standard stuff, standard work, because Bill at the time, who was he was on the EE spec. He wanted to work on some other areas, so I stepped in to work on the EE6 spec.
Cool.
And that's where that's kind of what led to me then moving into the core app server was from that standards work. That's when we were sort of defining web profile, as well as you remember, right?
Yeah, but this is the revolution. The Java 6 is I think where the true lightweightness started, I would say.
Yeah, that was when we finally were able to shed all of the stuff of E that people really weren't wanting for web applications. I think that made it. I mean, not shed it like as a permanently basis, but just allowing a configuration or runtime that did involve all the stuff that like JMS that you didn't necessarily need for a web app.
And so you started with the clustering in Java 6. One question: what is the actually killer feature of JBoss regarding clustering? Is something you really like in clustering, or unique feature, or?
Right. So one of the things that's nice about it is that we do have, because we have open source, real open source roots, but all of the components of WildFly or JBoss EAP. They're all independent community projects that we aggregate. So we tend to have quite a bit of flexibility. So the our clustering layers, you can configure it in a multitude of ways. You could use a distributed based clustering, where you have where you sort of, it's sort of, if you think of it from the perspective of of like RAID, where you combine the share total size, so you can have multiple nodes in a grid, and then the data is only stored on a subset of those. There's like a redundant copy that's kept, and you can configure that. So you could have a full distributed for your replication, or you could do a straight synchronous replication setup where you want every node to have an exact copy, so you have the maximum redundancy. You could configure the things you were talking about, synchronous, asynchronous. You can configure every aspect of how well it synchronizes. So if you want immediate consistency, you can adjust that.
But you are talking about the Infinispan clustering right now, right?
Right. So like internally, WildFly's clustering uses Infinispan. So like when you use, for example, HTTP session replication, internally it's using an Infinispan cache. Now we have to do some kind of advanced stuff because the semantics of clustering for EE components are not necessarily the default semantics if you were to use, say, Infinispan, for example. So we have some APIs and some hooks there that integrate the two technologies in a way that makes it work well. But yeah, I mean, it's very customizable. So you can take an application that, let's say you have an application, for example, that's like really heavy on state. You can configure the WildFly clustering layer to be optimal in that case, or you can have a case where you have an application that's that's very light in state, and then you can optimize that as well. Now it tries to do stuff automatically, but there's as automatic as you can make it, there's always that need to change something, right?
Okay. So, but the base model is like Infinispan is the data plane or the backbone, and all the stateful components will just use Infinispan to share the state, right?
That's correct. Yes. And there's some slight exceptions in that we have like a membership discovery type stuff that shares the JGroups channel, but it's not. It's not working with state, but in most cases, like 99% of the time, you're dealing with an Infinispan cache under the hood for all aspects of data-based clustering in WildFly.
Cool. Switching the gears here. Regarding microservices, what I notice is it's really hard to use JMS in distributed world, and not using JMS rather than setting up the JMS server. And what I already thought, it would be actually really interesting to misuse Infinispan as a JMS transport layer. So not actually using, the message server, because you could use Infinispan as a distributed JMS server, just as event mechanism. This should actually work, right? Because you could send a message which serializes, and it will arrive in all other application servers at the same time, right?
Yeah, you could technically use it that way. The only thing is just that it's really designed around storing state, which I guess you might want if you're looking at it, say like a persistent queue.
Yeah.
But the patterns are really built around sort of random access. But I mean, yeah, it'd be an interesting sort of research project to try to look and see how you could build messaging on top of like a JDQ.
Because the problem is, if you have to set up the GMS server, it has to run somewhere, right? And someone has to care about the clustering failover. And if you have so in my world, in my microservice world, the WildFlies are running in a Docker container. There's one-to-one relation between WildFly and the microservice. Mm-hmm. And if each microservice would put, the Infinispan, they could find each other, and we could communicate to each other using JMS in asynchronous way without actually having a central point of failure like the JMS server.
Yes, yeah. So you could definitely do something like that also with, but it'd be a bit lower level. Like JGroups has people
exactly. So
built systems on top of it to do exactly that, right? Sort of like they set up dynamically discover each other, and they set up a group communication bus, and then you can do that.
But this could be actually an interesting project, GMS via JGroups.
Yes, yeah, definitely. Definitely.
Cool. So you and now you're still involved with the clustering stuff, or are you just the project lead of everything?
Not as much. I mean, I'm involved in the WildFly clustering when we have like clustering, design discussions. I tend to get involved with every aspect of the server from a design perspective. But we have Paul Ferraro. He's actually the lead of the clustering in the server. So we each major area we tend to have someone who specializes in that. And then of course there's the Infinispan team, and there's a collaboration between all those folks. I mean, I tend to be pretty broad after moving into leading the project. So after I was on the spec, it ended up where I started to lead there for JBoss. Like the first release I worked on was 5.1 was the first release I led. And then which is interesting because we had just been through if you remember, like AS5, between AS4 and AS5 there was a big re-architecture. It took a while, and people were like, when is it coming? And then we delivered that, and then we went to 6, where we tried to, because it took a while for 5, we tried to speed things up with doing sort of incremental EE6 type stuff and milestones. And then and then we decided that we really needed, just the landscape of things were changing, and we kind of saw like a lot smaller devices and cloud and things like that being a possibility. So for AS7, we completely rebuilt the server from the internal architecture. So it kind of went through 2 major architectural shifts, and then that's what so that was the big basis of the first thing, the first major effort that I was really heavily involved in was re-architecting the server for being really lightweight, booting fast, having decent memory footprint, and so we still have that. So we've still been on that architecture since then.
Exactly. So what's the mission right now? So what is actually your main goals? So let's say, what is the vision, regarding WildFly?
Right.
So what would you like to achieve?
Right. So one thing is that we see the way in which application runtimes are used as being as evolving to being different. I mean, in general, like the software delivery model, we see changing where continuous delivery is like the future, right? Everybody's moving to rapid release, and then also we see microservices in the future, cloud native applications, and so you sort of see like a lot of the aspects of like the infrastructural server pieces of that you would have in an application server sort of evolve into becoming part of like the cloud platform. And then the application server sort of becomes more focused on being a runtime. And so our philosophy is allowing for these sort of smaller images of a service that someone would implement to be custom to really anything that you would want to do. So like right now, we've been very much we're the EE full platform, or you could be web profile. And then, we've always had the ability where if you look at WildFly, you could actually rip it. This is kind of like a JBoss history forever, right? You could always rip the server down to whatever you want it to be. You could slim it to whatever you want it to be. But
exactly.
But you have to there's work involved in figuring out what you want that to be. And sometimes you have to like catch dependency issues and stuff like that. I mean, it's not a hard problem, but it's certainly something where it's, there's some steps involved in deciding what to slim it to. So the direction that we're taking things is, so for the next release in particular, we're going to be targeting integrating a new provisioning infrastructure, although it's going to happen in stages. And the idea is that that it will make it really easy to slim and grow the server to whatever you want it to be. So we see that as being sort of like beyond those limited profiles that you have. So you could say, for example, I want exactly these capabilities for my server, and then you would get a very thin runtime that is exactly that set, and then your application would be a part of that. So make it really easy to build up and tear down the server, and then also make it easy to add in technology on top. So we already today do that, where if you look at, for example, like the JBoss data grid stuff, there's a server mode, and the server mode internally is built off of WildFly. And then we have things like the Keycloak project. I'm not sure if you've seen that, but that's like a SSO.
Yeah, sure.
Yeah, so that's based off of WildFly. So we have a lot of projects that are based off of WildFly. And so one of the things we're looking at is we can make it really easy to build technology on top of the server. And so that's another goal of this effort is to make it so that there could be a bigger ecosystem around it where developers could contribute technology that layers on top of WildFly, and then you could sort of pick the modules that you want when you assemble the server, and then you end up being able to do like microservices architecture with individual services that are tailored to what you want to do. So that's, in a nutshell, that's basically where we want to go. And we think that if we speed up our delivery cycle and then we add those, improve those customization capabilities, that it will make it a lot easier to build complex systems, by using WildFly.
Yeah, the provisioning you're referring to WildFly 13, right?
Right. So 13 would be the where we would introduce it internally. It probably won't be too interesting at that point, because we'll basically just be using it from an architectural perspective. But then in 14, we're going to try to start breaking. Like one of the things we want to do as a part of it is to break the server into smaller grained components. Because like right now you can remove elements, but if you want, for example, a transaction manager, you might end up where you have a dependency on JCA, for example, even though strictly that's not necessary. So that's kind of a big phase of it, is to break things into modules that can be easy to pick exactly what you need. So more flexibility. Okay. Yeah.
I see the point of building on top of WildFly. What I'm using right now is I always use WildFly full profile. I never use the web profile because there's not a lot difference between them. What I even did, and I don't know whether you saw this, I delivered a session, a Java 1 heavyweight versus lightweight. And a full hour, I just measured the performance differences or footprint differences between servers. And there were not that many. So actually, there was not a lot difference between WildFly Swarm and the full WildFly. So your problem is, I guess, the WildFly is already pretty thin. So even the full WildFly, if you start it boots very fast, and this is very lean. So I would say, if we strip down, if we remove, let's say, JSF, EJB, and let's say JCA, I would not expect, too much difference, to be honest. So This is we attempted this over and over again. Some of my clients, ask me, "Hey, look, we don't use GSF. Can we remove it?" So, okay, sure. If you remove it, we'll probably save 1 meg of RAM or whatever. Who cares about that, right? But but what's interesting is building something on top of it. So this is actually a more interesting use case, I would say. If you could use WildFly as the engine for a new, I don't know, SSO or CMS or whatever. So this is actually a compelling point. Making a Lina, to be honest, I don't know. And what I'm a little bit afraid of is, the problems with partitioning of the community. So what could happen that someone just uses the transaction manager and the other one would just use the CDI without the transaction manager, and then we get portability problem, what we had before J2E. So right now, at least, if I have J2E, I know the application will run on Payara, WildFly, or Open Liberty. After the tweaks, if every vendor will attempt to scale down the platform, then we gain nothing. So then we are, there is actually nothing compelling anymore about Java E or Jakarta E or E4J or whatever.
Yeah. So just one thing that's important is we don't have any intention of basically completely stripping out the technology and not shipping it. More what I meant was that, like, you would have a distribution. So you would say you would get WildFly 14 or WildFly 15 or whatever, and it would have all the EE technologies and probably more. And then, but you wouldn't when you actually go to build your application. You simply just say which of those things you're using, and then it would create an image of WildFly that would contain only those things that you've picked, right? So
okay.
So like if for example you have a need where now I really need a transaction manager, then that would just be a simple edit to a file, and then you've got a transaction manager. So it wouldn't be that now I have to go and do a major upgrade or anything like that, right? It's just it's basically just like the menu of components. You kind of think of it as sort of like a Linux distribution, right? Where you have a Linux distribution and it's got like 8 gigs of software or something, but nobody installs all 8 gigs. They only install maybe,
But even Linux, this is actually an interesting point. I use lots of Docker. And all my Docker images are based on Red Hat or CentOS. It depends on clients. And I always get the question why I'm not using Alpine Linux. And my answer is because it does not matter. So the Linux image is installed once per machine, and I really don't care whether I will save 100 megs per machine, yes or no. And with Red Hat or CentOS, I have the userland. I have exactly the commands which all my clients have, and I'm absolutely not interested, in investigated strange Alpine Linux commands.
Yeah, I totally agree.
This is what I mean.
Yeah.
So the lightweight craziness. So I see every day. I get question Java is too heavyweight. Can we strip it down? It's like no. So at the Java one session, what I did, I compared WildFly Swarm, and Payara to Hello World Java. So I just created Hello World Java with one thread. Block that, measured with JVisual VM the overhead, and then compare that to WildFly, Open Liberty, to all servers actually. And the difference was around 40 megs of RAM, 40 to 60 megabyte overhead. So if you will strip down all the components, what you can gain, at most 30 megs per microservice. I don't know about USA, but in Germany, RAM is extremely cheap.
Yes, right. So that's kind of interesting. So one of the things that we've seen is that when it comes to memory usage, that the biggest consumer is in
JVM.
Is related to the JVM space. In particular, you'll see it's not it's a percentage of that, but a big contributor to the overall JVM space is the whole metaspace measurement. So the actual the amount of code that you have in the running system can contribute. So we've had really tiny heaps for a long time. You could have a full profile server and have it using 16 megs of RAM depending on how you're using it, right? But what you'll see is the metaspace value will actually be a lot bigger than that. So the whole JVM could take up, depending on what you're doing with it, it could take up a couple hundred megs or more. And So and there's ways to reduce that. There's ways to optimize that. So, but that's kind of like the benefit is if you're able to reduce the running code in the system, you can reduce that size. Now, I agree with you. RAM is cheap. Where it kind of matters more is when you start dealing with, so cloud infrastructure, and you've got like, say, if you really embrace microservices and you have hundreds or even thousands of services all running, and you're trying to like test this stuff maybe locally on a test system or something. If you think about it, like the amount of memory the JVM uses times the number of processes you have, it can actually consume quite a bit of your laptop when you add in all of the,
Yeah, sure.
You add in your virtualization.
You are right.
Yeah.
But most of my project, I think, is also not very good architectural sign if you're building and if your project you have several hundred microservices. I think so. Most applications you could create with, I would say, 10 to 15 microservices.
Yeah, that's much more
really beneficial.
That's much more sensible. Yeah, it'd only be like in like the reuse scenario, right, where you start expanding, and then you've got enterprise or whatever, and they've got, I don't know if you've ever seen like the Netflix diagram or what I'm talking about, where it's a lot. So
but this is a dangerous area, My clients are not Netflix, so I always get the arguments Netflix and Twitter and Facebook. It's like, look, we are not Facebook, we have a small data center, we are building an enterprise app, we are not building a streaming service like Netflix. So but what I could see is actually in Java EE 7 and 8 full profile, there is a lots of stuff which you don't need anymore. What we could remove, for instance, is like the CORBA stuff, right? Yeah. CORBA, SOAP. Sorry for SOAP, but I didn't use SOAP for 10 years or something like this. So I would say I could ditch SOAP. And then what remains is actually a full profile, Java E7 profile, which is usable. And it is not officially the profile because cannot be certified anymore because some parts are lacking. But these parts are no more in use anymore, right?
Right.
So this could be a valid use case.
Yeah, and CORBA was CORBA was officially pruned in EE8. So so it's still there until EE9. Well, EE for whatever. Well, it's up to Jakarta EE.
Yeah,
right?
yeah.
but that I definitely see happening. The web services stuff, that certainly sounds like it could be an optional technology now that everybody's kind of moved to REST-based approaches.
Yeah.
So
sorry for that.
Yeah. So I agree. although from our perspective, what's sort of interesting is that we have like this mix of people that that are cutting edge who are building the latest stuff, and then we have users that they'll have like applications that still use some of these older technologies. So
sure,
that's kind of where the provisioning aspect is kind of nice, is because then only the people who are using SOAP or web services pay the cost for it, right? Because then they specify, I'm using web services, but then like in your case, you wouldn't be using it at all, so you would never specify that, right? But from a standard perspective, we should keep the spec pretty lean, I would say, and so I think that it makes sense to look at the future there, especially when you have sort of two technologies that do kind of the same thing. Why put a lot of investment further into web services technologies when you already have REST already out there? That's
I have to admit, what I see in enterprises, SOAP is dying rapidly.
Yeah. And
if you just take a look at conferences in those sessions, no one talks about SOAP anymore, I would say. It's just museum.
Right, yeah. And that makes sense because, I think it's sort of interesting because like one of the big promises of web services was supposed to be that you would be consuming services on the internet, right? Mm-hmm. You remember that, right? And nobody really, there was a lot of people showed it being used, but nobody really, I think the closest stuff was, I think Amazon had it with their AWS stuff. They actually had real web services, but everybody just went, just jumped on REST, and that was really it's sort of interesting. The REST became the ultimate realization of what web services was trying to do, and it did it with less technology. So that's sort of a lesson learned, right? You don't necessarily need to have a stack that does anything and everything to solve people's problems, and because people were able to build a lot of really great stuff on it, even though it didn't do the same amount of stuff.
So what we didn't cover so far is the latest news, right? WildFly 12 is out, and it looked to me like it almost completely supports Java 8. So what's not supported, I think, is the security stuff, the GSR 375, right?
Yes, and also JPA as well. And so that's going to be on the list for those two items will be coming in on the next release for WildFly 13.
In 3 months?
Yeah,
in 3 months, which is news.
Yes. And so part of the reason why I would have liked to have had JPA in sooner, but the Hibernate folks are currently doing some massive refactors and optimization of, so like the new Hibernate 6 is being worked on. And
what are going to be the features? Can you tell us?
Well, it's just it's all internal stuff, so you wouldn't necessarily be directly exposed to it. It's things like the actual process by which they generate queries. The whole engine that generates queries is being heavily optimized now to produce like the smallest possible query. Because in our when we've done performance analysis, it's gotten to the point to where one of their biggest limitations they run into is not so much because they've optimized the binding pretty heavily. It's the queries that hit the database, and like even just like the text size of the string can have an impact once you do a certain. I mean, this is very high levels of load that most people don't do, but but once you hit like a certain point, you actually find that the actual text space in the X2O connection consumes a lot. So to optimize the protocol, if they really generate the smallest possible query for any given result set, that actually they've seen some testing that makes a big difference. And then they also have like some legacy aspects of their architecture that have a cost. They can improve memory utilization and stuff like that by. So that's what they're doing. Hibernate 6 is just all in a lot of internal optimization. There are a bunch of new features as well. I couldn't enumerate those to you right now because I don't help my head.
It's okay. It's just refactoring. It's okay.
Yeah.
Everything is leaner.
Yes, exactly. Yeah. So that's the situation is that they actually have a 5.x release that has the new JPA stuff, but we're hoping that we can get on the new optimized one as opposed to the other one. But we still have to determine that depending on how the schedule goes, which we can pull in. But yeah, so JPA and the new security spec.
And why the security spec is late? Because in theory, it should even work on all the JBosses or WildFlies.
Right. In fact, the RI actually already works on WildFly. The only reason it wasn't was just the timing of things. Just due to our all of the other things that we were pulling in, we just didn't have the bandwidth to pull one other thing in. And then one of the things that we're trying to do with this new iterative model is that we don't, because it was very tempting. We're like, we're so close to EE8. Let's just finish it in 12 and release it then. But one of the frequent feedback that we get from the critical feedback that we get from the community has been, there's too much time between WildFly releases. We really would like to see more releases, and then we kind of see the future, and like I was mentioning earlier, continuous delivery, where the expectation is that you could pull in updates frequently from us, and then frequently update your application as well. And so this is sort of a step in that direction. So in that case, we do have to sometimes say, okay, well, this isn't right. We have to pick what's going into what we have time to do, and then this piece may have to get pushed to the next release. But since the next release is only 3 months away, it's not too, in the end, I think you end up delivering in roughly the same time frame. It's just that everybody who would not be using those capabilities can benefit from everything else we've already provided. So,
yeah. And so we get every 3 months a new WildFly right now.
Right. Yes, that's the goal. So we did that for 12, and so 13 is the same thing. Now there's if something happens, like there's a massive security issue that we uncover.
Yeah, of course.
Then we would not be on that. But we'd only be shipped by whatever that time slip by the time that is necessary to resolve that problem. But in general, yeah, every quarter we release, and then we'd have one of the things we're doing that's a bit different is that we're being a bit more. We're trying to do more of a continuous model where the branch is essentially in a state that is very close to being releasable at any given time. And so we're taking features that are being developed and we're doing those in topic branches, as opposed to, so traditionally the way we do it is you'd submit a pull request for a feature, it gets merged in, and then we go through this like polishing period, right, where we're testing it, finding problems, fixing it, and so in order to speed up, the big change we've had to make is to try to remove the uncertainty aspects, right? So now we try to develop the features in isolation, and then they get developed, and then they get tested and everything in a topic branch, and then they get merged in when they're ready. And then that helps us with hitting these sort of shorter time frames. So like the EE spec, like we say it's a preview edition because it's not fully complete of EE, but all of the different specs that we've included are actually fully complete implementations. So you could build a Servlet 4 or JAX RS 2.1 application and deploy it on WildFly without an issue. So it's not like a early beta or early alpha or anything like that. It's actually pretty a pretty good implementation. So.
And with JAX RS 2.1, you were ahead of time. I just saw in the email that you planned it for 13, and now it's out, right?
Right. Yes. So we were really happy about this because there was some just the REST Easy project was making some other changes, and so we weren't sure that the release was going to line up, but we were able to make it happen. So yeah, so that was part of the thing is when you look at, for example, like we could have included security, or we could put energy into getting JAX RS 2.1 in, and then JAX 2. That's the easy one for me, right? Because probably most web-based applications are using JAX RS in some way these days. From my observation, I'm not sure if you see the same thing.
Yeah. Of course.
Yeah.
And what's the relation to EAP? So is going to EAP will also release faster, the supported version of JBoss, or what's the plan there?
So right now, at the moment, EAP is still following the same model. But what's different is that because we're doing more faster iterations on the WildFly side, there's more WildFly releases in between an EAP release. So the EAP minor releases will probably be a little bit shorter between each other, but we still have the same sort of traditional cadence, and we may optimize that, come up with some additional changes in the future. But at this point in time, it's still largely the same. So in some ways, that's because we have a lot of customers who already have certain expectations about the life cycle. Support. Long-term support on particular branches.
And what's the official cadence? Once a year? What's the official EAP release cadence?
EAP releases do minors from 1 to 1.5 years roughly is the time frame. And it's largely driven by whatever the customer RFE payload looks like. So like if customers ask for particular capabilities, then what we do is we look for the upstream work that aligns with what they're looking for, and then try to ship based off of that. And then we have a certain amount of support, lifecycle support, long-term support on a particular branch. So we have to keep that in mind as to how many branches that we have out there that for users to use. So it's about every 1.5 years. And then we do majors about every. At the smallest interval, we do them every 3 years. But currently at this point in time, we intend to do a few more minors on EAP before looking into a major.
Is it actually possible to buy support for the WildFly? So let's say I'm really wealthy customer, with billions of dollars on my bank. Could I buy support for WildFly? Let's say I would like to have supported WildFly.
So we have a model called Community to Enterprise that is an opportunity for that sort of thing. But that's one of those things where our support model is still very much driven off of running EAP. So the C2E model is all about how you move from community to EAP. So
Okay.
so there is arrangements that we come to for customers that make this transition, but we don't have a just pure support just pure support on community, and that's it at this point in time. So
because what usually happens, we start with the newest WildFly.
Mm-hmm.
And if the customer has to wait 1.5 years to get supported, it's a little bit too long. So the great model would be if they go to production with the WildFly, they can tell, okay, now we can buy support and wait until the EAP arrives or something like this, right?
Right. Yeah. Yeah. So so that's currently what that model is intended to address, is when someone has adopted WildFly and they're using capabilities that are not yet in EAP. So they have this problem of, well, how do I move to EAP if I'm using something in WildFly? So that's where that was created. One of the things we try to do is to make EAP more accessible to developers. So you can actually download EAP for development by just having a jboss.org site. You don't have to talk to an account manager or anything like that, or get a license key or anything. You can just go and download it. So you could start building your applications on EAP with the eventual goal to evaluate it and then move to production support if you're happy with it, right? So that's another channel for customers to go in. Although we know that a lot of people are going to want to go the traditional community to EAP approach.
Okay. Some final questions. What do you like in Java EE the most? So what do you really appreciate in Java EE? At a spec or?
Right. So the thing I like the most is I think the productivity system, like the declarative model is really just a brilliant way to build software in my mind. It just changes you just throw some annotations on a class, and then you don't have to code a bunch of APIs. So I do find a lot of the sort of DSL APIs that are out there, various frameworks, that they are certainly appealing, and we have a lot of stuff like that, but I still find myself drawn to that declarative model where you don't have to worry about what your API call is. You just simply say what your needs are, and then the runtime fulfills those needs for you. So that's probably the thing I like the most. I really like the concurrency model with Java SE and EE. So that was one of the things I find the most attractive with Java, was the work on Java util concurrent. Which
exactly. This is widely underappreciated feature, I would say. This is just great. So, and I think it is also underspecified. So, if you look at the spec from concurrency model, the examples are actually more interesting than the spec. So, what should be standardized in the concurrency model is like behavior on overload. The whole what's called rejection policy handler, I think, right?
Yes.
So what happens in case the executor handler is overloaded? I think it's called rejected policy handler, and everything is in the examples, but it's actually not standardized. And this would be great, because then you can specify exactly how a thread pool should behave in case the queue is full, for instance, right?
Right. Yeah. I mean, I that's something. It's sort of interesting because the EE spec almost did something in that area. With the whole concurrency EE spec. I know it already delivered some that mainly amounted.
Yeah, this is what I'm talking about.
Yeah.
This is the Java EE concurrency utilities. This is what is right now available.
Right.
And what's unspecified is already within the spec as an example. So if you read the spec, there's just the injection of executor service. And then if you read through the spec, there are samples how to use that. And the samples are even more valuable than the spec, because they state you could, for instance, use abort policy, and you could have caller runs policy, like how it's called back pressure, and we can even drop tasks. And I think this is more appealing, and somehow there is not a lot's interest, or people are not aware of it. And this, for instance, in JAX-RS 2.1, we have reactive client. So with the RX reactive JAX-RS client, is this perfect case to talk between microservices. And what I always do, I can inject managed executor service from the concurrency, pass it to the client, and I have built-in bulkheads pattern. So it's actually this what you really need. And what right now, way to set it up is different on WildFly, Payara, and OpenLiberty, which is a pity, because all servers I know are based on executor service from JDK anyway. So it would be really very easy to standardize that.
Yes, yeah. I mean, there's certainly a lot of areas like that, and I agree with you that it would be great to make it easier to do that stuff. Certainly in a more declarative fashion would be nice with executors and setting up policies on how the behavior works. And that's kind of what application servers do, right? If you look, the thread, they sort of do that for you, and then you have like a configuration somewhere. But you're right in that you need sometimes you don't always want like the same thread pool policy for everything. You want a special case, and I agree that should be standardized or better standardized.
Cool. Next question. What is the killer feature of WildFly in your eyes, except of course clustering and except SOAP?
Right. Well, so WildFly, one of the things that's really nice about WildFly is it has a really there's a bunch of different things. So one is the flexible server runtime. So it can be sort of slimmed down and built up with just by removing subsystems in an XML file. So it's a pretty rich configuration. It has a very rich configuration model for nearly everything. So you can kind of really easily set it up to do what you want it to do. It has a great web server undertow, which we support things like you can run WildFly as a load balancer, for example, and it has very rich capabilities there. You can write non-block. You can write non-blocking handlers if you want to do asynchronous style development for web requests. And then just in general, like the philosophy of WildFly has always been what's valuable to the developer. So that's one thing I think we tend to have a really rich set of frameworks that you can use, right? So you can use Hibernate APIs directly. You can use Infinispan. You can use all kinds of different, all sorts of technology. So that's what I see as the strength of WildFly. I think we've kind of pushed the envelope too on being the lightweight runtime, and we hope to continue to do that. Yeah.
And what is the craziest or biggest or nicest WildFly or JBoss project you are aware of? I don't know, WildFly running on Mars, or millions of transactions per millisecond or whatever.
So I've seen all kinds of stuff like that, and I'm not sure what I can share.
Okay. It's just private conversations. So.
Yeah, exactly. Yeah. But so we have customers that do some pretty wild stuff. But I mean, I have seen a lot of things like that. Where now I don't know if it's running in space. I'm not quite sure about that. But it's certainly used in a lot of really mission critical stuff that it kind of blows my mind that people are able to build these really advanced architectures on this stuff. So yeah, it's customers and users impress me every day. I guess.
Okay, so we'll keep it private right now. Okay. Where people can find you or find more information about you, WildFly or WildFly News, or what are the resources?
Right. So if you go to the main wildfly.org website, there's a news feed there. And so you'll see notifications about releases. And then we also have developer content there. So if you're looking at, like, say, a new feature that WildFly rolls out, what we try to do is we try to have the team that developed the feature write up about how you use it and some of the cool things you can do with it. So that's also on that main site. I'm on Twitter as JT Green, with me at the end for Green. But there's also WildFly AS you can subscribe to, which posts a lot of stuff. And that's the sort of our main news channels would be social media and the website. We one of the things we recently changed is we're trying to improve our documentation. So if you look at WildFly 12, we're now doing ASCII dog generated as part of the build, and then we're trying to do it so that when new features come in, that that as part of the pull request, there's always some docs being added. So we really want to make that a better experience. But yeah, if you to go and get information from the docs, you just go and click the docs link, and that's sort of like the main touch point for users that want to get interested.
Okay, so thank you for the interview.
Thank you.